Hi everyone. In this class, we are going to start discussing about a single linked list in Python. How can we create single linked list? How can we perform operations on a single linked list? All the things we will discuss. So first thing is, here it is. So what is the purpose of list? And compared to, already we have seen that linear queue, compared to that linear queue, how that linked list will be useful. So normally if it is a queue, what is the problem? Whenever you are performing, see, I'm inserting the data. Suppose this is an array. We can say the dynamic array also is a global array also if you take. But suppose if you want to insert some element in the middle, insert some element in the middle. Let me take, suppose the value is 10, 20, 30, 40, 50, 60, 70. Suppose if you want to insert element into this location, some element I'm inserting, then what will happen? All the elements will shift to next location. All the elements will shift to next locations. Simply. Nothing but 70 will move here. 60 will move here. 50 will move here. 40 will move here. Then some value, let us take a 45. Then 45 will be inserted here. These things will not move. 30, 20, 10. 30, 20, 10. No need to move. These things will move as usual, like a 40, 50, 60, 70. After creating that, all the elements, all the right side elements, we have to shift. So suppose if I delete this element, then again in the dynamic array, all the elements will shift like this. Size also will decrease. For this, for insertions and deletions, because of shifting of elements, dynamic arrays are not recommended. Global arrays are not recommended. We always use linked lists. So in linked lists, suppose this is one link, is a node. This is one node. This is one node. This is one node. Suppose all these are connected like this. All these are connected. Suppose. So suppose if I want to connect a new node in between these two nodes, no problem. Just we disconnect this one and we establish the connection for this one. This one we connect. In the same way, and this one we connect like this. No need to shift the elements. Just in between, we establish the connection. In between, we establish the connection. So for example, I want to delete this node. Okay. Then we disconnect this one and we disconnect this one directly. This node we are connecting to this node. So insertions and deletions takes less time in linked list. But accessing is difficult compared to arrays because in arrays, indexing is there. With the help of indexing, we can easily get the information. Through indexing, we can easily get the information. But in this case, it is not possible. Instead of using that indexing concept, we need to travel from first location to that particular location. We start from here. If not there, we need to check. If not there, then we are getting some value. which is present. From the starting index, and nothing but from the starting node, we keep on moving like this. Okay. Next one is, there are three types of linked lists. They can call single linked list or singly linked list. Is a double linked list, circular link, single linked list, that you can directly tell, circular single linked list, and same circular double linked list. Circular double linked list. In single linked list, suppose this is the node, it holds data, and this is linking to the next node. Same, it is a data. First one is a data and is linking. Is a data and it is linking. Is a connection like this. Connection like this. Every node has, this is the node. Every node has two fields. One is a data field. Second one is a link field. This is, we can call it as a node. In double linked list, every node has three fields, data field in the middle, and is connecting to left and connecting to right. It's a bidirectional. Here it is connection to next node and connection to previous node. Is the same story. Is a connection to next node, connection to previous node. This is called unidirectional and this is called bidirectional in both the directions. So whenever you are writing the node, it is that left link, and this is the data, and this is the right link. All the three are there. Next one is a single linked list. Means what? Circular single linked list is connecting to this first one. That's last node again connecting to that first node. This double linked list means what? This one, that last node, right is connected to first node left. I mean, this one, and this is connecting to last node as well. Same only, single linked list and double linked list only. But two extra connections we are giving will become circular single linked list and the circular double linked list. That node creation is the same only. Single linked list and double linked list. The first thing we need to understand, how can we create the node? Suppose basic single linked list operations we are doing. In single linked list, I just want to create this node. Single node. Single node. Oh, what is that? What happened? Oh. This is the node I want to create. Here it is, I want to store data. Next one, I want to store link or next, anything. Just link or next node simply. This is the node I want to make it. How can we means what? Class is a node. Whenever you create the object, that node will be created. But that node data is, we know that using the constructor. Double underscore init double underscore self comma whatever the data you are giving, data, as soon as node you want to create, you need to send the data that will be added to that object data. But initially that next value will be none until you create. So what will happen with this one? Whenever you want to create the node, just suppose a new node if you want to create. So what you will do, you will create object now, and you need to pass the value 10 like this. Consider. Then what will happen? First, for this class, memory will be allocated. Memory will be allocated at some location. At some location. Right? Next one is a 10 will be assigned to this data. To this data, 10 is assigned. Next, a none will be assigned to next. To the next, none is assigned. And this 1000 is stored to that variable is a new node. That 1000. Once it is ready, then we are establishing the connection. Okay, just give me 1 minute. Parallelly, let me write the code to understand clearly. Just using that online compiler, any one compiler. It's a single linked list code. First, as usual, what I told that node I am writing. Node. I'm taking that define double underscore init double underscore self comma data. Inside that self dot data equal to data is a self dot none. Next is equal to none. That's it. It is just only node creation. Okay. Now everything I'll do from the linked list. So I'm taking that separate class is a linked list class. Linked list. See, here also I'm defining double underscore init double underscore self. I am giving object creation. Initially, starting node, root node we can call or head node we can call. Any name is a none. All operations I want to do from here, outside. Outside. First thing I'm going to create linked list. LL I'm giving. Confuser. Confused. Just linked. I'm using. Creating the object for the linked list class. This class. What will happen? What will happen? Object will be created. Their head is representing what? Null. Parallelly, let me write the code. Initially, head value is a none. Is a none. It is not pointing to any node. It is not pointing to any node. Simple. Only just a head is created, but it is empty still. Empty. Now, sir, I just want to create the node. For that, we are writing the code. In linked list, I'm defining one method called insert method. Which method? Insert method I'm calling. Whenever you are calling insert, please send the data, whatever you want to insert. Whatever you want to insert. Okay, I'm writing the code. Linked dot insert. I'm inserting 10. So this value 10 will go and store into this data. Into this data. So first, what we have to do? You need to create the new node. New node I am creating into variable. Suppose temp I am creating. Temp sending that same thing to data. Nothing but from here, I am creating the object of this node. Data you are sending. Then what will happen? I already told you. Here, one node will be created at some location. Let us take address 1000. That 10 will be added here. Next, that none will be added here. And once it is ready, then that address will be assigned to temp. This address is assigned to temp. This is ready, is pointing to this one. Node is created. Now simply we have to check whether it is a first node or already some nodes are there in the list. Sir, it is the first node only. Consider. It is the first node only. How you know that? If head is none, after creating this one, simply we are writing the code. If that self.head is none or equal to none, anything you can use, is none, then this temp means what? 1000, you have to place in this head. 1000. You have to place in this head. Then it is pointing to this node. Then it is pointing to this node. Is a way. Got it? Next. Once it is done, here it is simply to that head, we are adding that new node address. Temp is a temp. Simply you are adding that one. Sir, suppose if it is not that one, else. If it is not that one, it's not the first node. Sir, already nodes are there. Suppose list is like this. List is like this. Let me explain. Is a node. Is a node. Is a second node is there. Second node is there. Is a third node is there. Is a third node is there. Like this. And is 2000. And is it 3000. Suppose already data is there, consider. It's 20. Is a 30. In place of this none, it is a 2000 stored. Nothing but is connected to the next node. Next node. And is a 3000 stored. And is connected to the next node. And that last one is a none, consider. Is a none. Already that list has 3 nodes, consider 3 nodes. Now imagine they have called again this method insert. Like suppose already, just generally I'm writing inserting 20. Imagine inserted, insert 30, inserted, linked dot insert is a 40 inserted. Oh, sorry, 30. Now 40 they are going to insert. Now they call function call, then it will call this node. Look at this now clearly. This is executing. It is executing. Here, that address is a 4000 we are adding. That is initially stored into temp. Temp. Here it is a 40. Next one is a none. It is ready. Node is ready. Node is ready. But sir, where we have to connect, sir? where we have to connect. Sir, we need to connect here, but how to go? We need to start from the beginning node. Start from the beginning node, we keep on moving. How? Take one variable. Let us take a last, starting from the head. Head is what? Starting from the head. Head is what? 1000. Nothing but last equal to 1000 initially. Then we are repeating the while loop. While that last is not none. Simply until for that last next is there, then simply we are storing that last equal to last to next. Last equal to last to next. Now see, observe. 1002, next is 2000. Is there true? Then 2000 store into this last. It's a 2000. Now 2002, next is there. Yes, 3000. That 3000 will be stored. So is a 3000. Is a 3000. Now, sir, 3002, next is a none. None means what? While loop terminates, because already we reached. We pointing to this one last. So simple. Temp assigning to last to next. Just simply after while loop, last to next equal to temp. Just 3 lines of code. This while loop, why is there while loop you used means what? Because we don't know how many number of nodes are present in that given list. So using the while loop, we keep on moving until it reaches that last node. Until it reaches that last node. It's a simple one. Okay. Now here I'm doing the code. I'm executing the code here. First taking that, take one last node. Starting from that self dot head. Repeating that while last to next is there. Last to next is there. Store that last to next into last. It will keep on moving. It will keep on moving. Then finally, what we need to do? Finally, that last to next holds that temp, because temp is a new node. Temp is a new node. Sir, I just want to give that message that node is added or something every time. Every time that data added. The data added. Every time I'm just giving this one. I'm giving. So just to check the output, that's all. See, look at this. 10 added, 20 added, 30 added, 40 added. This is the simple way. So in place of this none, finally that 4000 will store. And it is pointing to this one. Once it is come out of the temp is just a local variable. All the local variables will be deleted. No? Deleted. Temp is a local variable. Last is a local variable. These are not permanent. Only one variable is a permanent. That is that head. Head is a permanent. Sir, next one is a simply I call display. Display or traverse, any method. Any method. That is what displaying the data. Define traverse. Define traverse. Simply saying that suppose if list is empty, so nothing but if self dot is the same one. If self dot head is none, just the empty list to display is empty list. If not, that list elements are, if not, the list elements are. How? So very simple again. We keep on repeating the loop. First, you just take into one temp variable 1000. Root value you keep into the temp. So while temp not equal to null, temp is not none, then we keep on printing. Print temp to data. After that, moving to that next, temp equal to temp to next. If 1000 not none, 1000 will print. 1000 to data, 10 will print. Then it will move to 2000. Print 20. Then it will move to 3000. 30. Then it will move to 4000. 40. Finally, temp to next means what? None. When it is a none, it will stop. When it is none, it will stop. So simply we are taking the temp equal to head we are taking. Head we are taking. And simply while temp, if it is there, then we keep on printing. What we are printing is the temp to data we are printing. Temp to data. After that, into the temp equal to temp to next we are storing. Temp to next we are storing. That's it. This is the loop. Now when you traverse is printing that list elements are 10, 20, 30, 40. 10, 20, 30, 40. This is the way we are finding. Okay. This is just a single linked list only for understanding that first program I have explained. I'll just drop this in that group. Please go through that. In the tomorrow session, all the things, right? All operations on the linked list, finding the length, add first, add after, delete first, delete after, swap. All the linked list operations I'll explain. Okay, you can leave for today.